Now, the history of this is that it started a long time ago. It really started back in 2006 when some people at Cambridge University thought about the way that computer science is taught, specifically in the UK. They were looking at what we have in the UK. Who's here? Who's from the UK here? Okay, reasonable number of people. So if I say ICT, some of you may actually know what I'm talking about. I can never remember what it actually stands for, but it's basically what we teach children at school in terms of technology. And so I have a 6-year-old son who does ICT. He gets to learn how to use a mouse, and he gets to draw pictures on the computer and things like that. So there's a curriculum for ICT. And the people at Cambridge University who were looking at this were rather concerned that what we were teaching children wasn't computer science. We were teaching them how to use applications, how to use a web browser, how to use a word processor, how to do email, which is not computer science. So if we want people to become engineers, if we want people to go into industry and create new things and have great new ideas, they need to be trained properly, and we need to start doing that from a young age. And a lot of their inspiration came from a project that actually happened way back in 1981, so just over 30 years ago now, which was the BBC Micro project. So, okay, hands up again. Who had a BBC Micro? Oh, okay, 1, 2. Oh, right, okay, it's a younger audience today then. So I had a BBC Micro when I was at school. It wasn't my first computer. My first computer was a TRS-80. Who remembers that? Oh, yeah, of course, it's American, isn't it? Yes. So, yes, I had a Trash 80. Great machine. 16 kilobytes of memory. Then I moved up to a BBC Micro. 32 kilobytes of memory. Wow. And colour graphics. What more could you want? But the idea behind this was to teach children and to teach adults as well about computers. Because remember, 1981 was way before the internet, way before general computing as we know. The IBM PC didn't come out until 1984. So this was all about getting people interested in computers and teaching them what it was. So they made this machine, and then they had a series of television programs that took people through the basics of learning BASIC. So the people in the Raspberry Pi project thought that was a good idea. How could they do something similar, but in the year 2006, or the end of the first decade of the millennium? And so they set about creating a device which they could use to teach children about programming in a way that they could understand, and, most importantly, make it affordable. They didn't want to be creating a machine that was going to be the same price as a laptop or the same price as a normal PC. They wanted something very, very cheap that you could give to lots of school children and have them get excited about these kinds of ideas. So it went through a lot of, it took a long time to come to fruition. They went through a lot of hard work and created this thing. And I was lucky enough to actually go and visit the people at Cambridge and go and have a chat with them just earlier last year, when we were talking about how to get Java to work well on the Raspberry Pi. So I had a meeting with them, which was very, very interesting to see it actually working and seeing how it was going. But then it was officially launched on February the 29th of this year, and it was very, very successful. Basically, the first production run that they did was 10,000 boards, and they produced them in China, and they were shipping them back to the UK mainly. And there were 2 companies that they partnered with to actually do the distribution of these things. One was RS, or Radio Spares, as we call them in the UK, and the other was Farnell. Both of these companies are very professional companies. They sell enormous numbers of electronic components to all the industries that use electronics. The launch of the Raspberry Pi board brought both of their web servers to their knees, because so many people were trying to buy these things. I remember I was trying to get on so I could actually buy one as well, and you just couldn't get onto the website. And RS actually said that they had over 100,000 pre-orders in one day, which is why it's taken a while for these things to actually get into circulation. So current production is about 4,000 boards per day. One of the nice things, certainly from my perspective, is that they've actually just shifted production away from China, which is where they had originally done production, and they're now doing production in the UK. So Sony have a factory in Wales, and they're now producing the boards for the Raspberry Pi organisation. So it's nice from a UK perspective. So let's talk about what you actually get in your Raspberry Pi. Well, the first thing is it's an ARM processor. And specifically, it's an ARM 11 core running at 700 megahertz. So that's probably about 8, 9-year-old machine, maybe a bit older than that if you compare it to a PC. I'm trying to think when I had a 700 megahertz machine that I was using. It's a Broadcom system on a chip package. So that means that most of the components are in a single package. And so when you look at the board, there's this kind of like chip in the middle, which is not the processor. That's actually the memory. The processor sits underneath the memory. So it's quite a clever design in terms of the board. The nice thing about it is you can overclock it. And just recently, the Raspberry Pi people have said that they will now allow you to overclock it up to 1 gigahertz, and you won't invalidate the warranty, because they're that confident of the production of their machines that they say that you can overclock it up to 1 gigahertz and it won't actually invalidate the warranty. I was at a Raspberry Pi meetup on Saturday, which was here in San Francisco, and there was one of the people from the Raspberry Pi organisation there, and he was talking about some of the details of that. And he said that there are people who have actually overclocked them to 1.2 gigahertz, but that does invalidate the warranty if it goes wrong. What you find is that you can continue to turn up the clock speed, but then you run into problems with memory access and it becomes very unstable. But it's worth knowing that you can crank it up a bit if you really want to. Memory is fairly, memory is fairly limited at only 256 megabytes, coming from a person who started computing with 16 kilobytes. But clearly by today's standards, 256 megabytes is not a huge amount. But it is amazing what you can actually do with it. Some of the sort of internal workings of the Broadcom chip means that because you've got GPU in there as well, you can do a lot of media processing without having to hammer the processor. And so 256 megabytes is still actually a lot of memory in terms of being able to do most of the things that you want to do. In terms of I/O, things that you've got to connect to it, you've got video, so you can either do that through HDMI or a composite video, so there's a phono socket that you can plug into. The idea with this is that they want people to be able to just use their television rather than having to buy a separate monitor. So the price is $35 for the board. What you don't want to have to do is then have to buy a monitor to go with it. That will be rather expensive. So if you can use your TV, that's great. You have to find a keyboard, you have to find a flash card, but it keeps the price down as much as possible. There are 2 USB ports. This is only on the Model B. Currently they're only selling the Model B. The Model A has less I/O on it, and it's also cheaper, so it's going to be $25 when they finally launch that. The Model B also has Ethernet on it, which the Model A won't, and then you've got a bunch of header pins that you can connect things to. So there's some GPIO lines, there's a UART for serial communication, there's SPI and I2C that's supported if you want to do more sophisticated kinds of I/O. There's also a couple of extra connectors on there, one of them which is designed for a camera. So there's future growth there in terms of being able to connect something like a camera to it.